Hello, welcome to PhyzQuest. So this is the solution video for CSIR NET December 2019 Part B, question number 9. The question is, a student measures the displacement x from the equilibrium of a stretched spring and reports it to be 100 micrometer with a 1% error. The spring constant k is known to be 10 Newton per meter with 0.5% error. So we need to calculate the percentage error involved in the estimation of the potential energy expressed as a formula V is equal to half kx square. 4 options are given and we need to choose the correct option. So let's get started. So this question comes from the section Mathematical Physics and the concept involved here is error in measurement. So when we talk about the error, when we measure a quantity, it is not possible to get 100% accurate answer. Some sort of uncertainty is always involved. It is not that because we measure it wrong, but it is because of measuring instrument. When we measure with the same instrument, every time the result may not be exactly the same. You can take the example of a weighing scale. When you hop on it, every time you will not get the exactly same result. Maybe there is some sort of variation is there. So that variation in the result create uncertainty. That is called the error in measurement. Now there are basically 3 types of error. First is the absolute error, second is the fractional error, and third is the percentage error. So we'll discuss them one by one. First is the absolute error. Absolute error is actually the difference between the measured value and the actual value. So suppose we have we measure a quantity and its actual value is suppose it's equal to a, and the measured value is equal to a plus delta a. So absolute error in this case will be equal to the measured value minus the actual value, which is equal to plus or minus delta a. This is very simple. Next is the fractional error. Fractional error is actually expressed as a fraction of the actual value, the original measurement. So actually it is the ratio of the absolute error to the actual value. So absolute error we have already calculated. So this, if we put in this formula, this will be equal to the modulus of the measured value minus the actual value divided by the actual value, which is equal to delta a by a in this case. Next is the percentage error. Now percentage error is actually when fractional error is expressed in terms of the percentage, that is called the percentage error. That means when you multiply 100 to the fractional error, it will give you the percentage error. So here percentage error will be equal to, using the formula for fractional error, it will be equal to measured value minus the actual value, the modulus, divided by the actual value multiplied with 100. So here mathematically we can write this as delta a by a into 100. So these are, now here whatever we have discussed here, we have considered a single quantity a, that is only one quantity is measured and its error are analyzed. Now suppose there are situations where the quantities which are in, there are multiple quantities involved, or suppose there is any quantity whose formula involves several other quantities. So what to do in that case? So here the error measurement with the contribution from multiple quantities. Now when a quantity is has a contribution from different other variables, that is in any formula it has there may be the involvement of other quantities with the relationship of sum or difference or product or division or power. So any kind of relationship is there. So in that scenario, how will we calculate the error? Now for example, first of all we will consider when there is involvement of sum or the difference. So let us suppose we have a quantity C is equal to A plus or minus B. So here the error in this quantity C will be equal to delta C, which is equal to delta A plus or minus delta B. This is very simple. So how about when there is involvement of product or division or power? So let us take the example of any quantity. Suppose S is equal to A to the power M, B to the power N divided by C to the power P. So in this expression there is involvement of product, division and the power. So how to calculate this error in this case? So first of all we have to take the ln of both the sides. So when we take ln from both the sides, left hand side will be ln S, which is equal to, here since power is also involved and when we take the ln, so it will be equal to m ln A plus n ln B minus P ln C. So now after taking ln, next step would be to take the differentiation of both the sides. So when we take the differentiation of both the sides, this will be equal to delta S by S. LHS will be equal to delta S by S. So right hand side will be equal to m into delta A by A plus n into delta B by B minus P into delta C by C. So this is actually expression of a fractional error. So now to calculate the percentage error, we have to multiply 100 here. So this will be equal to delta S by S into 100 is equal to m into delta A by A into 100 plus n into delta B by B into 100 minus P into delta C by C into 100. So as you can see here, if we need to calculate the percentage error of this quantity, we should know the percentage error involved in these quantities and we can calculate it accordingly using such type of formula. So we have to follow this type of procedure to calculate the fractional or the percentage error. So now let's move ahead with our question. So here we have a stretched spring and we need to calculate the percentage error in the estimation of the potential energy. So for a stretched string, the potential energy formula is already given, V equal to half kx square. Here k is your spring constant and x is the displacement of the spring from the equilibrium. Now a student measures the spring constant k as 10 Newton per meter with 0.5% error and the displacement x as 100 micrometer with 1% error. So using these values we have to calculate the percentage error in V. So we will follow the same procedure as followed previously. So here we have V equal to half kx square. So first of all we will take ln of both the sides. So it will be equal to ln V is equal to ln half plus ln k plus 2 ln x. Now next step is the differentiation. So when we differentiate it, it will give delta B by V is equal to 0 plus delta k by k plus 2 into delta x by x. First term is 0 because this is a constant term. When we differentiate it, it will be 0. Next, to calculate the percentage error, we have to multiply with 100. So this is delta V by B into 100 is equal to delta k by k into 100 plus 2 delta x by x into 100. Now here, if you look at the right hand side, left hand side will give you the percentage error of the potential energy which we want to calculate. Right hand side we have this delta k by k into 100 is the percentage error in the spring constant k, which is given as 0.5%, and this delta x by x into 100 is the percentage error in the displacement of the spring from the equilibrium, which is also given as 1%. So we just have to put these values. Instead of delta k by k into 100 we will put 0.5, and in place of delta x by x into 100 we will put 1. So this will be equal to 0.5% plus 2 into 1%, which will ultimately give you 2.5%. So 2.5% is the percentage error in the estimation of the potential energy. Now let's look at the option. So if you look at the option B is matching with our result. So correct answer for this question is option B.